A warm greetings from Rohini College of Engineering and Technology. I am Professor Radhika from Chemistry Department. In this video lecture, we discuss about the constituent of composites. After completion of this topic, students can be able to explain the importance and development of composite materials. In this previous video, we have discussed about the composite materials need, its advantages, etc. Now we move to the classifications of composites based on the constituents. So generally it is classified into two types. One is matrix phase and another one is a dispersed phase. Matrix phase are otherwise known as matrix resins. Dispersed phase are otherwise called as reinforcements. Matrix phase is the continuous body constituent which encloses the composite. The matrix phase may be a metal, ceramics or polymers. Composites using these matrix are known as metal matrix composites, ceramic matrix composites and polymer matrix composites. Similarly, dispersed phases are otherwise called as a reinforcement. The dispersed phase is the structural constituent which determine the internal structure of the composites. Example, fibers, particulates, flakes and viscous. Let us see the metal matrix phase. Okay, so the matrix phase has several important functions. It binds the fibers together by virtue of its cohesive and adhesive characteristics. It acts as a medium by which an externally applied load is transmitted and distributed to the dispersed phase. It protects the individual fibers from chemical reaction with the environment and from the surface damage due to mechanical abrasion. Therefore, the matrix phase helps to protect. Similarly, dispersed phase is the structural constituent which determines the internal structure. Already we have discussed. This picture clearly indicates the dispersed phase and matrix phase. Now we discuss the examples of dispersed phases. One is fibers. Fibers are long and thin filament of any macromolecular substance such as polymer, metal or ceramics having a length to diameter ratio at least 100:1. The fiber can be used in variety of forms like continuous rovings, cloth, chopped strands, etc. Any polymer, metal or ceramic that has been drawn into long and thin filament is termed as fiber. They have high strength and stiffness. Orientation of fibers determine the property of fibrous composites. Some of the fibers are glass fiber, carbon fiber, aramid fibers, boron fibers and ceramic fibers. Then we move to particulates. The dispersal phase in particular composites consists of particles. These particles can be metallic or non-metallic. The properties of matrix materials which are modified by adding particulate fillers are improved performance at elevated temperature, improved uses and abrasion resistance, increased surface hardness, reduction in cost, modification in thermal electrical conductivities. Therefore, particulates are a small pieces of hard solid materials. Generally, it may be metallic or non-metallic. It's a distribution of particles in a given matrix is random, so that resulting composites are usually isotropic. Due to the inherent hardness, the particles in a composite cause constraints on the plastic deformation on the matrix. Then we move to flakes. Flakes are very thin solid like materials. It has a two-dimensional geometry. It gives equal strength in all directions. It can be packed more efficiently than fibers. Spherical particles. Its important character is it gives equal strength in all direction, and it is packed more efficiently than ordinary fibers. The best example is mice flakes, which are used in electrical and heat insulating applications. Then whiskers. So whiskers are very thin single crystals with high degree of crystalline perfection. It possesses high strength. The example is graphite, aluminum oxide, silicon carbide and silicon nitride. Okay students, thank you for listening. In our next video, we discuss about the other type of composites. Okay, thank you.